Hello, everyone, and welcome to episode number 26 of the Hyperthesis podcast. My name is Patrick.
My name is Pheely.
And I'm Liam.
So today, since it's around the holidays, and some of you may already be celebrating some holiday traditions of your own, we figured we kind of go away from discussing topics in general, like what we've done in past episodes, and just kind of have a bit more of a chill episode where we're just talking about updates with our research and just seeing where this episode goes. So we don't really have a planned topic. We're just going to, I guess, wing it in terms of what we're discussing. And so hopefully there's some still useful information that we're talking about, but this is just a relaxing episode that you can put on maybe as you're decorating the house or preparing a dinner for family or friends, and just enjoy being present with each other. So as an intro topic, something that I learned about very recently, it's what's known as coppicing or coppicking. I'm not quite sure the pronunciation, but as someone who's interested in forests and forest management and how things like that occur, this, I guess, practice is essentially where you chop down trees, but those trees themselves then grow back from where you've chopped them down, essentially. So there are a lot of different types of trees that are able to regrow from their branches or from their roots. I think the largest organism, at least by mass in the world, is a single tree that has a whole bunch of different, what look like individual trees, but they're all connected through their roots. So these types of trees can also, some of them can be cut down essentially, so you can use their wood, but you don't have to go through the process of planting a tree again because they're essentially little saplings grow from the body of that tree again, almost like branches growing from a tree.
Yeah, it's like banana is how it works, right? You don't plant banana seeds. You cut a piece of it of like the trunk and plant it, or you cut part of it, it's just grow into two. I remember reading about this. They said like, what is the largest organism on Earth? And it's not the whale, it's not the blue whale. So it's some kind of fungus that connected, basically live like under the city, or it's just like a huge network of things. And to me, there are some people that that's kind of creepy, right? And like you have a network of trees that does the same thing. But sometimes I think about this. Imagine if trees are treated like animals, right? We are cutting them and let it grow back. That sounds like really cruel and inhumane, but nobody cares. Like I think of like cows just eating grass, and you're like, each bite it just took a life, right? Like,
I know there have actually been some serious studies on whether plants and trees can feel. And turns out, like, when you start cutting down a tree or shaking a tree or damaging a tree, it actually releases things that are similar to, I guess, hormones in our body that trigger different things to happen. The same thing happens within trees where they're like, oh, I'm in danger. Ah.
well, which is a really natural response. You can't just have like living organism getting killed and not do anything, right? Like I think is like if you look at the biological standpoint too, that's why like some plant like garlic produce certain chemicals or peppers, right? To basically get the pests or unwanted animals or insects away.
Yeah, it's interesting to see these, I guess, biological reactions happening in something that we don't really see as biological, because trees are pretty stationary. They don't move. They are alive though. But this method of coppicing was really popular in parts of Japan. I think it was referred to as daisugi. Again, apologies if I'm pronouncing that incorrectly. But sugi refers to a Japanese cedar, and essentially this was a pruning technique. So they would kind of prune the tree so that it would have very nice, straight, vertical growing branches, and then they would just cut the branches off and then they would regrow. And this produced very straight pieces of wood, which were excellent for building houses and other types of things in Japan. So yeah, it's still damaging the tree, but it's, I guess, a less harmful way than just cutting down the tree and waiting for some new sprouts to grow.
I think what you can do with trees, like I think it's called grafting, where you like cut off some branches of like if you have like an apple tree, you cut off branch and then you can tie another type of apple tree branch to that. They'll like fuse together. Next thing you know, you can have like an apple tree with many different types of apples growing out of it. I mean, as far as tree ethics go, maybe that's not a good thing, but I think that's really fun. I want to have like an apple tree that has 20 types of apples growing on it. I think that's cool.
So I will say remember reading that most apple trees are actually grafted. So they take trees that are better growing. So especially crabapple trees. Not many people enjoy crab apples, but crabapple trees themselves are great for providing the nutrients and liquids needed for growing nice big apples. And then they'll like put Honeycrisp on one side and then Macintosh on another side. So if you go to a lot of orchards or things like that, there will be probably grafted trees, and almost every apple tree is actually grafted.
Yes, things we do to plants is the GMO with the animals is sometimes look back like wow, trees, animals, and there's different level of care we give them. Like nobody cares if somebody kill a cockroach, like or a fungus, but you can't do that as animals. Like you can do skin crafting on humans, but people don't try to grow different types of skin at different part of the body. I think there's a huge ethical and moral issues there. Well, I'm no medical expert, but I think we can all see what could go wrong.
Yeah.
Um, just kind of speaking of that and delving into a slightly different topic. Another thing I saw that's related to, I guess, humans changing the world. It was a chart showing the distribution of mammals on Earth, and just kind of looking at the total mass of all the mammals, and also changes within that mass over time. And so, humans currently make up 34% of the global mammal biomass. So that means if you take all the humans together, weighed them, versus all the other mammals, it's 34%. Now, livestock and pets make up 62% of the global mammal biomass, with wild animals being the remaining 4%. So it's kind of insane that domesticated animals and humans make up 96% of the mammals in terms of mass on Earth.
E-
It's the absolute species dominance, right? Like because we grow in size because of our intelligence of us being human. We use tool, used fire, and we grow. So we got to eat. Actually, there was an argument that if we have to make farmlands for everyone and stuff, like we take a lot more like area than sometimes have hard livestock because livestock also can feed a lot more people. Especially like winter and stuff. If you go to like rural Russia, or like what are you gonna eat in the winter when like 6-7 months a year, even in Canada, right? When all the plants just got frozen, so they had to eat meat. And I think that's like it just maybe at the time the only way of living, right? Like what do you eat up there? You go live in Nunavut or North Territories or some place that like groceries can be very expensive, and you have to eat whatever animals that survive there.
Yeah, I know it's very interesting. I mean, we became so I guess such a powerhouse species partly because we do eat meat. Sorry to the vegans in the audience, but we depended on meat for more energy to be able to hunt for longer. And I guess we're at the point now where we're very fortunate that we have enough alternatives to, I guess, displace meat, and we're actively trying to make fundamental changes to the agricultural sector by reducing the amount of, I guess, animal byproducts such as methane that's produced to help the globe. But yeah, it's crazy our impact.
Yeah, I think about meat eating thing, it's about moderation, right? If you look at like a Canadian food guide, up until a few years ago, it was really bad. It's like I think it was like a lot of meat as on the bottom pyramid, which I grew up in Asia, and it wasn't the case. Meat is at the top of the pyramid because we don't need that much of it, and it just depends on like there's this cultural and historical reasons to right way why people are not like maybe in certain countries are not eating as healthy as certain countries or become the norm, like go to restaurants here and everything is cooked in butter. you know,
We should find a way to like graft tree branches to ourselves, and then we can just photosynthesize. It's like the most efficient way to get energy. I think we should do that. It'd be like cyberpunk, but with biology instead of metal. You'd be putting trees on yourself or leaves. Would you have hair if it was made of leaves? I think I would. Except in winter, I guess it would all die away and you'd be bald. That might not
If
be
you
as.
get needles, though,
What?
needles like needle leaf trees.
Oh, yeah, it could be a pine tree.
no, you just need to create a device that the solar cell that charge you. You just plug in your stomach and here's your pure form energy. Just you have like a little module inside you. It's like here is it's like a transformer for for biological energy and electrical energy. Yeah.
If you could cyberpunk yourself, so you could get like in the future, if you can get like body modification and be like, oh, I want a hand with 8 fingers, or I want like a robot arm that I can lift things with, or I want to run really fast with robot legs, or like I want bionic eyes. You could get the next Apple eyeball. Would you do that? I don't know if I would.
Well, I actually played a video game, the Cyberpunk 2077.
Well, yeah, that's what I'm talking about.
I tried to play. I tried to play as human as possible. Like, and I don't even use guns. I just use punches, and it was make my game very difficult sometimes. I actually had to get a body mod at the closer to the end, like the gorilla arm, so I can punch stronger. But apart from that, I don't know. It feels like like a what's called opposite of people think. You want to mod as much as possible. No, I want to walk in this cyberpunk dystopia being as human as possible in this where everybody was modding themselves.
Interesting. Well, just so we don't get too sidetracked and start doing a whole episode on Cyberpunk, which is a really good game.
I've never played
Maybe
it.
we can.
I've heard bad things about it, honestly, but
It
I
it got better.
okay.
But let's just transition into our main discussion, whatever that happens to be. I know we said that it'd be nice to give some research updates. So what we've been working on since our last update, many months ago. So how are things going?
Well, I've been developing the Apple eyeball. Um, I don't know about so. I don't know if you want to go first, Lee or Patrick.
Well, I don't know if you heard of the Elon Musk neural link. I have nothing to do with that. I'm just joking.
Yeah.
Well, I've switched gears from the let's go warship stuff into well a more theoretical ish. I don't know. I'm doing the machine learning research, but not using machine learning, but to basically analyze and find tools to understand machine learning better because now it's like a black box where everybody just put their problems in and there come a solution here AI machine learning we have even if we know what's going on mathematically inside we don't have the intuitive idea about how machine learning work and I've been working on trying to use physics to basically shed some light on that issue, how training work, how things are. So I'm just writing pieces of code that basically work on neural networks. I still have it's still early in the project, so I have a lot of work to do, and sometimes just feel a little burnt out. It's like, oh my god, this is difficult. This is not easy, and so I feel like I have a good idea what I'm supposed to do, and I have some hope of what it could be. But the national research is like, I don't know if it's gonna be a thing. I don't know if it's gonna pan out. So let's see how this goes.
Very interesting. As someone who has to use machine learning in their research, a big issue that we have with it is the fact that it is a black box. You can't really describe, okay, we use this type of method and it worked. We're not quite sure how it worked, but it worked. So I think figuring out and delving into these black boxes that are these machine learning algorithms is very important. So, yeah, that's fantastic.
Yes, like how do you decide what algorithm to use? How do you decide what type of gradient descent you're gonna use? How do you decide what type of activation function you're gonna use? Like there are so many neural network architectures out there, but people just I think you do this like heuristically, where you just do it trial and error. Maybe this would work better, but like, well, is there a performance matrix that actually come from understanding rather than the results, right? It's like physics. If we know how projectile motion work, we don't have to, try to throw a ball and land in certain area every time. We know exactly how they work.
Yeah, isn't it the way these like machine learning things work is that you have this black box and there's an input and an output. You kind of know what you want your output to be, or at least you know that you have all these constraints for your output. You say like, I want to create a machine learning algorithm to create like a car that can drive a racetrack in a video game, and you take this car and you put in this code and you make it drive a little bit and maybe it like drives off the track, and then somehow in the black box it'll learn, it'll be like, okay, don't do that, and then it'll fix it a bit. But I think it's just like, yeah, you put all these constraints in, it minimizes and or maximizes a bunch of things in the code, and then it decides, okay, this is the best trajectory or something.
Yeah, I talked about this last time a little bit too, that the backpropagation is one of the most important piece of code in human history, that just small piece of code that tells the neural network or any network to learn from the quote unquote mistakes or the results, right? And I think like what you were saying before is basically like that, right? It's an optimization algorithm. It tries to minimize, or what physicists would call it, free energy of the system. You try to find a minimum, and that can be a problem, right? Like you have local minima, which are not the true minimum, right? But at the if you crawl certain way, you might find a lot of local minimas, and you might not know that there are way more efficient way just right by because you couldn't get over that local well of minima, like a minimum. And people, the free energy landscape in neural networks are very complicated. That's why there are not many tools to figure that out right now. Maybe there are some that I don't know of. A lot of these are done in like private sector, which they don't exactly like to share because it's capitalism, competition makes sense.
Classic capital. Even in like academia, you have competition and stuff. Well, it's like go to a conference or you present at a conference and you don't want to talk about everything you've done because you don't want to give other people your exact ideas so that they'll steal them. I mean, I don't worry about that too much, but I know a lot of people do, especially in like quantum computing and information. Anything where there's money involved, you know what? You're right. It all comes down to capitalism, and even in academia.
Yeah, the world is run by commodity, right? So life is a competition. If you look in a biological standpoint, it is in a way a competition. Even biology say, the contribution to the gene pool or something is like called fitness, right? How fit are you in this environment? It's like the principle evolution, and it's kind of tracks along to humans too, like the society that we are in now. Anyways, I want to hear what you guys have been up to too. Any takers?
What have I been up to? Just I've been in this QED class right now, this quantum electrodynamics class. Yeah, I think I talked about this last episode actually, but anyway, I don't really need it for my research. I'm just kind of interested in quantum field theory and fundamental forces of nature. So, I'm punishing myself for being interested in things, but that's fine. As far as research goes, I've been kind of continuing my acoustic black hole stuff. However, I've been coming at it from a more mathematical point of view. I've been looking at I've started looking at anyway, I'm kind of continuing my work for my main project. Lots of math, lots of asymptotic analysis, which is all stuff I've talked about before. And I also have this secondary project I'm working on now, so that's kind of new actually, where I'm studying these things called Gross-Pidievsky breathers. They're essentially you take a ultra cold gas called a Bose-Einstein condensate, you trap it in some walls in some shape, you then remove those walls, and put in a harmonic oscillator potential, which the physicists out there will know about. And then this shape, so if let's say you start with like an equilateral triangle, 2 dimensions, BEC gas, um, it begins expanding, but then it will eventually recontract to its exact initial shape, except kind of flipped when it rotated 180 degrees. And then it will just keep doing that over and over and over again. I mean, theoretically forever, but realistically not forever. So I've been studying those things with an undergraduate student. So that's been kind of cool.
Well, you talk about this breather before, I believe, and I want to ask you, like, because you take the QED class at Pi, right? It's Perimeter Institute. How's that like? Because you heard about this kind of institute, it's like the they compile or aggregate like the most brilliant people on the planet and do the thing. This is as like you know, or is it like when you walk in, does it feel like that? It's very like what's the experience like at Pi? I've never been there.
Yeah, so this class I'm taking through McMaster, but the guy teaching it, Cliff Burgess, who actually we talked about last episode a little bit. He's on my supervisory committee, and he's a physicist who does this thing called effective field theory, and he does all kinds of gravity stuff. I think. Anyway, really good physicist. PhD supervisor was a Nobel Prize winner called Steven Weinberg, and Steven Weinberg unified the weak force. I think why he got his Nobel Prize, and I don't exactly know what that means, but maybe someone else does. Anyway, big physicist, and Cliff is no different. Knows all this stuff. So he actually works at Perimeter Institute, but he has this like affiliation with McMaster. He's also a professor at McMaster, and I think that's a pretty common thing at Perimeter Institute, which is located in Waterloo, Ontario. So Perimeter Institute is this big building associated with Waterloo, and it's like a theoretical physics building essentially, and maybe there's some experimentals in there, but like its focus is theoretical physics. So kind of like the best quote unquote theoretical physicists from Canada. Well, that's what they advertise at least work there. So when you walk in, the building's really nice. It's a super nice building. Like when you go in, they have this kind of like sitting cafeteria area right on the inside, but it's called I think it's called like the Black Hole Bistro or something like that. Because of course it is. And they serve like I think they serve breakfast and lunch, supper, and like alcohol and stuff. I've only been to Perimeter Institute about 3 times so far now, but the building's super nice and like the classrooms are just incredible and they have really nice chalk and like the classroom I'm using has 3 chalkboards all next to each other, but they're those sliding up and down chalkboards. I think in total there's there's 9 chalkboards in one classroom, and they also have it automated now. So they have whenever there's a lecture or a class, over Zoom they stream it, but they have these cameras that are kind of mounted on the wall, and the cameras will automatically follow whoever's at the front writing and teaching. So as they go between their chalkboards, the camera follows them. So it's very fancy, and yeah, there's a lot of really smart people there.
Have you heard of the Hagoromo shock? I think that's it, like one of the best shock on the planet. That it doesn't squeeze. It writes neatly, and is the powder is
What is it?
perfect. That was it was like you probably seen some videos, heard some news about this chalk from like Japan or
Oh,
Korea.
yeah.
Yeah, that people are sought after. All the mathematicians just want them because they're the best chalk. That
I don't
you
think
know.
that's the kind of chalk they use. Although I don't know, it just seems absurd that the entire building only uses that chalk. but like it's pretty nice chalk. Like you write in the board and you're like, ooh, this feels good.
If you contract it out, right, we're gonna need maybe 500 boxes of chalk every 6 months. You better just like go to the department and it's like, all right, everybody order a big batch, right? And I think that chalk story is pretty not neat. I think it was a Japanese company, but I think they didn't do so well, and the Korean company bought it. It's like a license or recipe or something, and start selling it again because there's so much demand in the academic world, which is for pure mathematicians. Though not that many, but if there is a market, there's business to be had. So I personally, I think I've tried a chalk once in one of the professors. I don't remember who, but it just feels like when you use fountain pen for the first time, it has that nice, pleasurable feeling.
So just about the Hagoromo chalk, they actually shut down in 2015. So that led to like essentially mass hoarding by mathematicians and physicists of the chalk once they went out of business. But they sold their 3 custom machines that made the chalk. And apparently there's now a company in South Korea that makes it that's said to be indistinguishable. But there was mass panic when they announced that they were shutting
It's
down.
hilarious. He's like, I have like, honey, we have guests coming over. Get the good chalk. Like that's so funny.
Oh, I feel like some of us like use niche thing that people don't think about it, like chalk, right? Like I love my fountain pen inks, and if the company went under, I was like, I would be really sad. For some people would think a stupid reason. It's like, man, it's just your ink, but like it's a great ink, and I've been using forever. You know what I
I
mean?
think the ink I'm using with my fountain pen now is actually they don't make it anymore, and it's not like this super exquisite expensive ink. It's just like a nice ink that's pretty cheap. So I'm kind of upset about it because now I have to probably buy a more expensive ink, or else I'll get a really bad one. I haven't used my fountain pen in like a year actually. I gotta clean it and use it. I've just like been lazy essentially.
Yeah, I've used it all the time, and I don't know. I just feel connected to writing more when I use fountain pen. Sounds weird. I started in like high school. I was just like, I like writing, and no, not I don't mean by like I write novels or anything. I like the act of writing on the paper. I don't care what's writing. Writing equation has a kind of pleasure that you don't get from, I feel like you don't get from writing anything else, because you see this succinct, beautiful mathematical description of certain things and be able to draw these symbols as not your language, like Greek symbols. Like who used that, right? And or maybe the Greek use, but if people to write that after people look at your papers like, man, it look pretty nice, but I don't know what that is, which is I think is the coolest thing, because when I go on a plane sometime, a long trip plane, I'll bring my notes and start just doing my research there, because like, then when I talk to other people, I realize like what we do sometimes just looks like nonsense to a lot of people. Just like, what is this crap?
Yeah, at my theory club meeting the other day, we had kind of a more chill one, and we all just talked about whatever we felt like, kind of what we're doing today. And it kind of hit me there because we were all standing around a board, and people were just writing math on the board, and I thought it was really cool how we're all speaking this kind of language, and if some random person walked in and looked at it, they wouldn't understand. But you can take like anyone in the world who knows math but doesn't speak another language, and they would all kind of look at it and know the exact same thing without even having to talk about it. I thought that's kind of neat.
Yeah, about me writing fountain pens too is much more like higher maintenance than other like type of pen, right? You can't just grab it and write it. Sometimes you have to, like, you learn the nature of your pen. You know where the sweet spot is, where the inks flow best, and there are this whole craft to how to write with it and how to take care of it. And some people ask me why I go through all that effort, because when I actually write, I feel like I'm a part of history. I'm a part of, because writing to me is more than just an action that draws stuff on surface. Is connected to how the mind works. Like, is one way to basically embody your thoughts onto the physical world, and the way you do it is matters. At least to me. I mean, some artists would say, the way they choose paint, they choose the brush, right? They choose the techniques matter in their art. I'm not writing art, right? But I want to have that like connection with my action. I don't know if people would get it. Maybe people who write with fountain pens would get it. Like sometimes I grab my typewriter and start to type because I want to realize what it means by typing. What is typing? What human from history that come from drawing to writing, and now you are typing. But the origin of typing has come from this mechanical old typewriter. What people first felt when they felt the Gutenberg Bible, one of the first beautifully printed book ever, is still now beautifully printed book, right? There is to develop that Gutenberg printing press there's this entire history that I'm fascinated about. That maybe I should learn more about it, but since I'm in physics, I know a lot more science and stuff, which is fun. But I like to be able to immerse myself in this part of history.
You've been a different person ever since you took that philosophy class, Pheely. I've got to say. Uh, no, that's actually really interesting. I yeah, I just like the way a fountain pen feels, and that's kind of it. I mean, my writing is my writing looks like I'm 7 years old sometimes, so I I don't take pride in it. Honestly, I'm ashamed of it, but I just like the way a fountain pen feels, so I have a great time with it.
I had a really bad writing until like grade 3. Until this teacher, she's like super strict, and she was like, now everybody is gonna start, spelling and writing well. And I think that's when the school moved from pencil to pen for the first time, and you realize you can't just erase your mistakes, you know. So I had to commit. So when you write something, you commit, and you better write it well, because when you come and look back at your work later, try to understand it or read your notes, you better do it well. And it stuck with me for many years. People say when you go to university, your writing is gonna turn bad. You can do lecture really fast. But you guys seen my notes from university, they're fine.
Yeah, your notes are very nice. I don't know, my writing probably is worse than I when it was in third grade, in all honesty. Something about the way I hold my pen is just wrong. Like I hold it like I'm left-handed, but in my right hand. Also, the way my fingers position is just bad. Like I've never really tried to fix it. It works for me, but I probably should put some time into making it slightly neater. Um, yeah. So Patrick, tell us about what you've been up to. You on any more adventures, more trips?
Well, I guess I forget where I was last time, but I did go to Costa Rica again for some field work, which was interesting. So in Costa Rica, the area where we are researching the forested area, it's seasonally dry. So last time I went there in February, it was dry. So imagine Canada in the winter, or a northern hemisphere place in the winter where all the trees are off their trees, but it's like that because it's so hot instead of so cold. Whereas this time all the leaves were on the trees, so it was a lot more lush and nice to be in. Other than taking a lot of data in the field, we're using this cool LiDAR backpack where we just strap essentially a LiDAR sensor that's rotating quite quickly to our back and then walk around trying to recreate these forested areas in 3 dimensions. Just been working on a lot of analysis for trying to figure out the best way to measure biodiversity of these tropical dry forests. We had a lot of data come in recently, which is exciting. And currently I'm working on trying to create artificial models of these forests. So actually getting the tree height, the crown area, and all these different tree properties simulated based on real world data. So that way we don't just have, say, 8 data points. We can have thousands of data points from these simulated models to really confirm if our theories work or not. So a lot of my work recently has just been in coding and working on forest simulations.
Yeah, actually listening to this about all getting basically creating models, I want to correct myself from a few episodes ago with Pablo. I was talking to him about like, well, 50,000 particles sounds like a lot, right? At least to me, and then I did some research after. Like Patrick, you have thousands of trees, right? But I heard, well, I actually talked to my supervisors that, well, the current MD, like molecular dynamics simulation, they can go up to billions particles. And I was like, what? I thought it's really hard to do like 1,000. He's like, no, people have been using techniques to do like hundreds of millions of particles and run on like this you think it's super computer, but like a super computer. It's just the crazy computers. And so I'm not surprised anymore that people like start to model this forests or things that have thousand and upon thousand, hundreds of thousand things in it, maybe using computers because they can now.
Even like when you do those particle simulations, you put like individual interactions between every single particle. Like, how can you do so many of them? Because that's ridiculous. Or there must be like a cutoff, or you can put in some approximations to like maybe in like a more macroscopic description of all the microscopic interactions. I don't know.
Well, I mean, I think from Pablo's research, they are trying to look at those individual interactions. So it's not really something you can simplify by looking on the macro scale, but instead there's a lot of simplifications that you can do, and also there are some pretty efficient algorithms out there now that let you, instead of being like, okay, this is our particle, this is our radius, this is exactly how it interacts. It's okay, we're gonna take like two properties of the particle and then just run that in the simulation.
Yeah, I think with but if you think about like how fast computers are, right? You heard about the CPU clock speed could be like 4 gigahertz. That's like 4 billion times of calculation per second. That is a lot. We can't do that as humans. I can barely do two. Like but they do like billions of time at once. And you think of GPU, you have many cores that do that at once. So I'm not that surprised actually that I hear people do up like millions of particles.
I will just add that GPUs, their actual measurement for calculations per second is a flop. So one calculation per second is one flop. And so we have these supercomputers that are able to do petaflops, which is you have giga, tera, peta. And even we're getting into the exaflop region, which is 3 orders of magnitude higher. And it's just getting insane the amount that we can calculate with
Who names
computers.
these things? It's like, yes, a petaflop. I think that's hilarious.
I think they actually just came out with some new naming for even higher levels of things that was released, and they are truly silly names.
I like that in physics too, when people like they basically meme in order to do things. Like what is it? You got like macho particles and WIMPs. And, I mean, there's a bunch of stuff. I can't think of all of them now, but like you see it all the time.
Yeah, sense of humor in science sometimes is a little strange. Even though I notice with me and my friends when we talk about this funny theory in physics or funny joke, like I make an effort to send out like for my theory club email every week. I include a meme. That's like sometimes like man, it's funny, but it's probably funny only to us. It's so funny, but I know a lot of people don't get it because it's like it's such an inside joke.
It is kind of funny though, especially with professors. There's so many professors' offices, both in the physics department and the Earth and Atmospheric Sciences department, that have comic strips on them, and like they're usually related to their research. So there's a lot of XKCD comics on their doors, or even like Bizarro, or just a whole bunch of comics that they'll have on their doors and they're funny.
During our undergrad, I had the famous meme wall on my desk, which was just like an entire wall of physics memes essentially. And I started doing one in my new office in 2019, but then COVID hit, so I never got to finish it. It's like 1/10 finished. But I really like so funny. I really one of my favorite memes is it's like the Anakin Skywalker image saying like I've become more powerful than any Jedi could ever imagine. But like the quote above, it's like the first time you use calculus of variations to prove that the shortest distance in flat space is a straight line. Like I've become more powerful than any Jedi could ever imagine.
Yeah, I mean, when I look back at those, I was like, man, that is funny. And then I look at some of the professor's jokes. Is it physics professor jokes like that jokes on like a second order expansion? Like, yeah, it's like that joke, but with science. I was like, man, I know why they think it's funny, but I was like,
Well, it's
come
like,
on.
it's like bad jokes and stuff. Like it's funny, but you kind of shake your head and sigh when you hear them.
I remember, I think it was in a fourth year calculus related course. It might have been complex variables, but we had a professor who was quite dry with everything. And he cracked one joke. And I'm pretty sure we were laughing, himself included, for a good 5 minutes because there was this one joke that we were completely not expecting from him. But that was that was a very memorable
Oh, that
moment.
was the complex course, right? Yeah,
Yeah.
I mean, I did like decent in it, but I remember not focusing as much as I should have, and now my entire like graduate degree is in the complex plane. And I'm just very upset at myself for having not taken advantage of that course.
I haven't used complex numbers since we left undergrad, I think. Or maybe some place, but maybe some computational course. But like in research, everything I do is
I'm
real.
so jealous.
It's funny because I'm not in physics anymore and I don't do physics research, but even I'm still using some complex
Oh God,
numbers, which is
you
weird.
use complex numbers in your work.
Uh there's a lot of it's similar to complex analysis, almost like complex variables, but it's essentially using different domains. And that's also kind of relates to my machine learning work, but it's different ways to analyze data essentially, and look for relations between different points of data.
To me, complex number is one of the one of the big thing connecting arithmetic or like algebra to geometry. So if you have anything that has to do with geometry, you probably need to use complex number to deal with it. If that data can be visualized in certain way, and there are if you want to integrate certain thing, you need to go to the complex plane.
How do you explain complex numbers to someone listening who doesn't know about them? I I feel like that's very hard to do because I would have done it by now if I knew how.
Well, I would recommend like children's books. That's how I learned about complex number. I actually don't like the word complex number. I like the word imaginary
Well,
number.
before
It's
well
much more
before you go
fun.
on, there's a difference between imaginary and complex numbers. Imaginary number, like there's real numbers, like 1, 2, 3, 4. There's imaginary numbers which we denote by this letter I. So you have like I or 2I or 3I. And then complex numbers are when you have a number which consists of both of them. So you have like 5 plus 5I or something.
So just to clarify with I, so I, which denotes an imaginary number, that is essentially the square root of -1. So you're taught in high school, oh, you can't take the square root of a negative number. That's just something that doesn't happen. But we can, and then we call those numbers that are square roots of imaginary numbers or square roots of negative numbers as imaginary numbers. So that's where I comes from.
We still cannot, but we just name it I. you it's just a weird thing that normally when you say it 1 divided by 0, we just call it ill-defined, right? But somehow square root of 1, we is not call it ill-defined. We define it as something we call
It's
I.
in the way I think of it, and like the way I think of it is probably a very naive way to think about it. But yeah, imaginary numbers aren't real by definition. And well, you don't see them in nature. I don't look at a table and be like, I have two imaginary cups in front of me. It's like, no, I have 2 cups or whatever. But imaginary numbers, complex numbers, you kind of, in mathematics, at least in my research, you use them as a tool. Quantum mechanics, imaginary numbers just appear everywhere. Quantum mechanics is a theory that involves it's theory in complex space. It has complex numbers, but it doesn't spit out anything that's imaginary in real life. You always The way you do it is you like you have a wave function which describes a quantum state, and maybe it has some imaginary part to it. Then you always kind of take this thing called the complex conjugate of it, multiply it by the original thing. So basically, in the end, anything that happens in the real world, you end up getting rid of all the imaginary bits, and you're just left with something real. So something, yeah, what you were saying. If you're trying to do some math, real numbers, sometimes you can't do it, and you have to go into the complex plane, do it, and then it spits out something real. But like, I have a pretty naive view. I'm not a mathematician.
Well, I think one of the important part of complex number is
Yeah,
conjugate, is because there are times when you square something, it turns out to be a negative number. And that could be very useful. Like you think about it, like you multiply two things that you always get positive number. Man, that sucks, right? Like that sucks. Sometimes in geometry that it is not true. There are certain symmetry that would not do that. So like how you explain it, you need something that you can multiply and get basically the conjugate, right? You get negative in front of it, like or like the anti-symmetric things that we have in quantum mechanics, like with fermion, like is you need that, right? You can't have everything be boson. You just square it, you get positive number. Well, fermion, you have this anti-symmetric wave function, but yeah.
yeah. Complex numbers are weird, but they're pretty useful. It turns out, like, again, you can't do quantum mechanics without them. So half of the modern technology, more than half of modern technology in its development probably involves complex numbers, and they appear everywhere. But yeah, they're kind of weird sometimes. I hate having to deal with them. It's just pure real numbers is really easy compared to complex numbers, I find.
Well, when you learn in school how to divide, right? Like it's much easier, and then you learn how to divide with complex number, which is like much significantly more complicated, right? To do those operations on complex number, you had to learn these new rules and stuff. But when you think about it, like in the fundamental level, right? What is a square root of 9? Like you can, it's because it's 3 times 3. But what is a square root of -1? You have to find something that multiply itself, and you get -1, and you just can't think of one, right? That's why it's so imaginary. Just call them I. Let's just give a symbol to it, and the rule is you square it and you get -1. That's
Yeah,
it.
that's a super clever way to do it, and that's what that's what you do in math and physics all the time. You're like 1 + 1 = 3. Oops, I guess there's this missing hypothetical number we're missing, so this hypothetical one that we've missed. Yeah, you just kind of said we don't really know what the square root of -1 is. We're just gonna call it I, and then boom, the property that defines it is that when it's squared, it gives you -1.
Think of all physical constants. It's the same logic, right? You create all these models, and there's this factor that always come up. Like, well, just call it something, right? Like pi. Pi is really the ratio of the circumference and the diameter, right? Like is we see it all the time, which this is why it's real. It's a rational number, so we just call it something. Right? I is the same thing. We call it's like, well, this is square root 1 all the time. Well, square root of -1 all the time. What are we gonna do with it? We just figure we just put a symbol to it. That's pretty good. And I've still hung up on that comment you make, Liam, about that after the philosophy class I've
Yeah, you
changed.
much more philosophical now, which is it's a good thing. Like you have some deep thoughts on things, and I tend to be just like, well, I don't care about that. Like, who cares about that? But I think being philosophical is a good way to live sometimes, although might might give yourself some headaches, honestly.
Yeah, I actually don't like to think that people change. My idea is that people don't change or don't become something else. They just be the version more the version of more themselves. They'll be more themselves every time. Because I look at myself, I was the same thing. I had these thoughts, but I just never able to define it and rationalize in this way. But it's not like I'm changing who I was. One of the big thing that I learned, actually one of the first philosophy class, which I never took until in university. It's like, yeah, well, why not? Let's see how that goes. I didn't know much English. Let's see how difficult it is to take a philosophy course, which at the time which at the time I was taking a English course too. It was a lot of language barrier to hurdle over. But one of the first thing the professor said was like, all the class you take, it's like science class, engineering, actually almost all auto class you take in university teach you how to do something, right? How to perform a task, how to solve problems. But they never teach you how to live. And that broke me. I was like, that is true. Nobody told me what is a good life. Only society told me what's supposed to be a good life. And there are thousands of years of people giving these ideas on what is a good life and how you should live, or like different models. As scientists, we come up with different models of what human life, what the optimal human life would be, or like the most fulfilling. Some people think is pleasure. Some people think it's this grand imperative that we have to do. Or maybe there's a God's plan. Maybe there's a plan in the universe. There's just many doctrines that come up in ethics and morals that I don't think a lot of people ponder about, because without knowing it, if you don't know Stoicism, like you might have applied some of the aspects of principle at some point, but to learn them formally and between maybe 10 and 20 different systems, and it's like science, you learn all these systems of how nature work and you choose to believe. Maybe Liam doesn't like to believe the one electron theory, which is very foolish of him. um, See, there are a lot of belief or things that come up in philosophy that if you don't study it, it's like what Plato said, the non-contemplative life is not worth living or something. You don't listen to the old man, do what you
Yeah,
want.
I'm not opposed to believing the one electron theory. I don't want to. I don't want it to be true, you know? Like if it is, then what does this mean for the universe? It's like, oh god.
Yeah, I think we'll definitely have to do a nice like discussion on the one electron theory, or maybe we can do it in an episode of sideline theories in physics and give, I guess, give them a place to make their
Maybe there's more
case.
to it than I know, and maybe I'm wrongly saying it's dumb. Like, I think mathematically it makes some sense, or else it wouldn't be a legitimate theory. But physically, I do not like the idea that there's only one electron in the universe. That like, and it just kind of jumps around between space time somehow. I just hate that. But again, I'm sure when Einstein first said, "Well, time depends on your speed," people were like, "Well, that's dumb." Here we are.
It's kind of like a loophole theory, right? It's kind of hilarious because you think of all exceptions you have to make when you build theory, and one electron theory is like, I'm gonna jump on that and just take it very far. It's like, oh, because we assume this thing and everybody accept that we assume that, like the position momentum, like, oh, we assume that. Like one electron theory, like, I'm gonna make your assumption my main, like my building block of
Well,
everything.
that's something that blows my mind too. Is that a lot of physics? It's not like you derive some equation. You start with some equation, which you just kind of like postulate. You're like, all right, F equals ma. It makes sense and it matches data. Like I don't really know how this works, but I'm always told that like Einstein's field equations, like he just kind of wrote them down one day. He didn't. They weren't something that was ever derived. They were just written down based on some constraints and assumptions. And I find that hard to believe, but it must be true because I've been told it many times. Like Einstein's field equations are wild. Like how do you just sit down and be like, of course, the universe, and then write that down?
Well, some people say it's a geometry thing. It's just come out of geometry. And to me, about these like scientific process or like even mathematical, it's axiomatic, right? You define what you
Yeah,
accept, what you have to accept. There, I remember learning quantum for the first time in quantum one. That's more of like a crap quantum, which is like you just solve a bunch of equation. Here's how it works. And when you get to quantum two, you're like, all right, we're gonna learn quantum formally. We're gonna start from the axioms, right? What do we assume? What is wave function? What do we define as a building block of things? And then we derive from it, which we can see a lot of that in formal logic, in philosophy, in these stuff where like how do you know how you start like an ethical theory? You have to start from assumptions like, oh, is human nature good or bad, right? You have to decide that first, or maybe you assume something else that's not that. There are some assumption, and then all the logic is derived from it formally. That's, to me, the difference between physics and philosophy is this empirical part and mathematics, because you can have all this formal logic with symbols all you want. It doesn't, it's not as, at least to me, it's not as rigorous as doing the calculus on it, doing the math on it, and be able to show to an really explicit and like a clear picture, description that this is true. In philosophy, there are still discussions or like, oh well, maybe the phrasing of things, or maybe it's what it meant, and a lot of philosophers are not that great at writing. Well, might get into trouble for this, but I hate Kant. I think Kant has great ideas, but he is a terrible writer. Who would want to read those like convoluted stuff? Like, masters, maybe I'm a scientist, I'm a little bit of mathematician. I look at Thomas Aquinas' work, it's really logical. You start from the contradiction and you answer it. It makes logical sense. And then you look at some other writers, like even to me, like Nietzsche, Kant. I'm going off here, but it's just my frustration.
I like how like in mathematics you can do these proofs, like proof by induction and all these things, and it like proves something based on some axioms or some statements or whatever. I like in physics because you do all this in physics, but at the end of the day, everything in physics is just proof by lack of counterexample, because you can say like a theory is a theory, but like if it's right 999 times, you only need to disprove it once, and then it's like, oh, it's wrong.
That's actually not true for the standard model. It's been have many counterexamples. Like every time they run the collider,
Well,
there are
yeah.
like counterexamples everywhere.
Well,
We
no,
still
but
accept
it's
it.
everyone who does knows anything about standard model particle physics knows it's not complete, right? Like, it's not a correct theory. There's problems with it, and that's what we're working to fix. But like you take general relativity, which is like Einstein's creation. We say, all right, this is our new theory of gravity, and it's perfect. It works. Lack of counterexample. But then you realize, oh no, black holes. It doesn't work for black holes. Here's a counterexample. So our theory's wrong, and we need a better one.
Yeah, it's like what our former supervisor said. The good theories are fallible, right? They have to be able to be proven wrong. Is why one of the reason why string theory doesn't is not as well accepted, because it's infallible. You can't prove it wrong. There's always a wiggle room for it to what's it called, lie themselves, or like trick themselves out of the contradictions. So it's like, well, if you can never contradict it, it's not a good theory. Good theory, you should be able to contradict it, and you experiment and say, oh, it doesn't contradict it. It's a great theory.
Well, I think speaking about the infallibility of theories might be a good place to wrap things up in our very casual conversation that's gone from fountain pens to string theory. Do you guys have any final comments?
Um, Good question. How's everyone doing?
Yeah, I'm just thinking how when this gonna air, because I'll be at home probably, enjoying the 30 degrees weather somewhere. Just take a little break. I haven't seen my my homes for like 5 years. It's quite a long time, and some friends I grew up with since I was like 6 years old. I haven't seen them forever, and to me, it should be a good break. Sometimes I forget what it means to be home. I got comfortable being alone. Because new country, new place, you have to at least be somewhat comfortable being alone by yourself and be independent. That sometimes I forgot how I grew up, and with all this big community, with family, with friends. That I have friends here, but this different. Like it's my second language here, and be able to express my mind in my first language, which I haven't used regularly for many years. I actually don't remember how to like actually like socialize. Like, I don't know. Like, I talk to friends and family sometimes, but it's not like you're there with them hanging out every day. So I'm excited to see how that happens, and I hope it turns
Yeah, I
out
think
well.
that'll be a really good time for you. I'm excited to hear about it.
Agreed. And so I guess to everyone listening, and Pheely, I hope you find you're at your home no matter what that is, this time of year, and that even if it's uncomfortable, you find a way to appreciate it. So, just before we wrap things up, I'll let you know how you can find us and contact us. So, if you would like to ask questions to us or make suggestions for topics, or if you would like to be a guest on our show, like in our previous episodes, you can send us an email. You can find us at hyperthesispodcast@gmail.com. So, we check the email regularly. So, if you have anything you want to say, let us know. You can also find us on Instagram. We're at the Hyperthesis, where we post updates. You'll get notified when we post an episode every Friday at 9 a.m. Eastern Time. And you can listen to us wherever you get your podcasts. So whether that's Apple Podcasts, Google Podcasts, Amazon Music, Spotify. We're based out of anchor.fm. And we also have a YouTube channel. So go ahead and check that out. We're also Hyperthesis Podcast. If you search for that on YouTube, you'll find our videos. So feel free to like, comment, and subscribe. Absolutely destroy that like button. I think that's what we're supposed to say. But yeah, check us out wherever you want to, wherever you prefer. And yeah, thanks for listening.
Well, and I want to say, like, closing remarks to 26 episodes, that half a year. We have 52 weeks in a year, and we're doing this for half a year. So thank you, everyone, to following us along to this point, and thanks all the co-hosts. It's become quite it's a great time. It's been a great time for me every week. So, all right, I'll talk to you guys next week. Take care.
Bye, everyone.
See ya.